Hello. At school, I was taught that George Stephenson built the world's first railways. Like a lot of things I was told at school, it was a half truth at best. Isaac Newton once said that a lot of the work he did on mathematics, gravity, and optics had been possible because he was standing on the shoulders of giants. In other words, great people before had paved the way. George Stephenson could have said the same thing. He and many other railway pioneers like Brunel and Hackworth stood on the shoulders of a giant whose attempts and mistakes made their achievements possible. So let's talk about the giant in question. Richard Trevithick was born in Tregoven, Cornwall, England in 1771. His father was a mine captain. Nowadays, we'd call him a mining engineer. Cornwall at that time was full of tin and copper mines. In fact, mining in Cornwall dates back to 2150 BC, and by the 1700s, it was one of the biggest mining centres in the world. With widespread smuggling going on, though, as well, it was a pretty wild and lawless place, very different from today's holiday destination. Trevithick was tall, about 6 foot 2 inches, about 1 metre 88. So by the standards of that time, he was a real giant. He wasn't very interested in traditional schooling and was self-taught. He had a natural aptitude for engineering, and because of his aptitude, by the age of 19, he was already working as an engineer in several mines, looking after the steam engines. A quick word about the steam engines of this period. The first recorded pumping engine was the Newcomen engine installed in Dudley, West Midlands in 1712. You can see a working replica here. James Watt greatly improved the design and teamed up with the canny Birmingham industrialist Matthew Boulton. They had all the patents and effectively had a worldwide monopoly on steam power at that time. For Richard Trevithick, the problem was that all of these steam engines worked with steam at very low pressure, no more than 15 pounds per square inch. If you wanted more power, you had to build a bigger engine, and they were already enormous. The answer was high-pressure steam engines. He couldn't produce these without infringing the Boulton and Watt patents, but he tried anyway. On one occasion, Boulton and Watt sent a lawyer to Cornwall armed with a writ ordering Trevithick to stop his research. Trevithick had the lawyer hung by his feet over a mine shaft for an hour or so and then sent him on his way. No more lawyers appeared after that. In 1800, the patent expired and Richard Trevithick accelerated his work on high-pressure steam engines. Watt once said that Trevithick should be hanged for exposing people to machines that could explode, and often did in the early years when the boilers failed. Trevithick's solution was the safety valve, which he invented. It let off steam when the pressure became dangerously high, an expression we still use today. His first vehicle, in fact the first working road car, was the Puffing Devil. As you can see, the replica made from the original drawings goes quite well, as did the original. Until one day, after a successful run, they parked up and went to celebrate in a pub. The fire in the car evaporated all the water in the boiler and bang, the whole thing exploded. Although this seemed a failure, the explosion only occurred because no one was looking after the engine. The Puffing Devil was just an experiment. Trevithick's next project was a genuine business venture. And here it is, the first London bus. The London carriage could go at up to 9 miles per hour, about 14.5 kilometres per hour, and carried 8 passengers. The roads in the capital, like all roads at that time, were really rough, so the carriage had extra large wheels for a smoother ride. It performed well, but it was expensive and inefficient, and people, or many people, were afraid of it. It never caught on. Finally, Richard hit on a winner, or so it seemed. Since the 1600s, coal mines had been using railways, or wagonways as they called them, to move coal from the mines to the ports. They used these wagonways because of the hilly countryside, which didn't permit the construction of canals. The advantage was that on a good road, a horse could pull almost a ton, and there were very few good roads. On a railway, the same horse could pull about 5 tons more quickly. If they worked for horses, why not for steam engines? He built a steam locomotive at Colnbrookdale, Shropshire, which was then the centre of the iron industry. You can see a working replica here. It ran efficiently, but the problem with iron wheels on iron rails was that the wheels tended to slip, especially in wet weather. Wet weather being an important factor in England after all. This locomotive only weighed 4 tons. His next project was part of a bet between 2 mine owners in South Wales, and the locomotive he built for this weighed 7 tons. The greater weight would grip the rails better. It was called the Penny Darran. It pulled 10 tons of iron and 70 men along 9 miles of track at a speed of about 5 miles an hour. A great success? Yes and no. The extra weight solved the slipping problem, but only for a very short time. The heavy locomotive broke the cast iron rails. It would be George Stephenson who solved this problem more than 20 years later by using wrought or worked iron to make the rails. Working the iron rails broke up the crystalline structure inside the iron and made them much stronger and less brittle. By Stephenson's time, the invention of rolling mills made this type of iron more affordable, and it took the railways to the next stage. This is the story of Richard Trevithick's life. He was full of ideas that were ahead of his time, and he went on with many more projects, but always struggled financially and never achieved the success he wanted. In 1808, he built the Catch Me Who Can locomotive that went on show in London. It ran on a short circular track and was the first train to carry fare-paying passengers. Most people saw it as a novelty ride, and it didn't attract the interest he needed, the interest of investors. He went on to work as a mining consultant in Peru. He explored parts of what is now Costa Rica, but none of his projects made enough money, and he died forgotten and in poverty in 1833 at the age of 62. He was buried in an unmarked grave. However, his innovations in steam power revolutionized transport and paved the way for those who followed him. Today, Trevithick is remembered as one of the greatest inventors of his age, or of any age. Well, I hope you enjoyed this episode. If you did, please click the like button and subscribe if you haven't done so already. And also, why not share it with your friends? Bye for now.